हाँ शुरू कीजिए।
Good afternoon, everybody. जितने भी फैकल्टी मेंबर, जितने भी स्टूडेंट्स, रिस्पेक्टेड प्रिंसिपल सर और इवेंट गेस्ट हमारे मिस्टर केतन पटेल सर, सब लोगों का बहुत बहुत स्वागत है वेबिनार सीरीज के इस 24th एडिशन में। अब एनजीपी की तरफ से कई वेबिनार आयोजित किए गए हैं और हर वेबिनार का अपना एक स्पेसिफिक गोल है, एम है और कुछ ना कुछ सभी वेबिनार से फ्रूटफुल निकल ही रहा है और हम सब लोगों को नया कुछ सीखने को मिल रहा है। इसी क्रम में आज हमारा वेबिनार है वो है हाइड्रोजन प्रोडक्शन टेक्नोलॉजीज एंड चैलेंजेस, जिसको प्रेजेंट कर रहे हैं केतन पटेल सर। वेलकम केतन सर। और ऑफिशियली वेलकम के लिए हमारे आज के जो कोऑर्डिनेटर हैं प्रोफेसर निशांत सर, उनको हम इनवाइट करते हैं। ओके निशांत सर, ओवर टू यू।
थैंक यू मैम। Respected principal sir, all faculty members and all participants of this program and my dear students. Today's topic of the webinar is hydrogen production technologies and its challenges. For this webinar, our very learned speaker, Professor Ketan Patel sir, has joined with us. Very welcome to you, sir. And let me introduce him first. Mr. Ketan Patel sir is a research scholar at the University of Adelaide, Australia. He is from Bihar only, and he did his Bachelor's of Engineering in Mechanical Engineering from MIT Muzaffarpur. Then he moved to United States of America for doing his master's, and while doing his master's he began his research career also and worked on various projects there involving synthesizing nanoparticles. That was his research area, and he also got opportunity to work with the scientists from the US Army Research Lab. And before finishing his master's, he published his research work and he became a published research scientist, which is not very common for any master's student. So it is a great achievement, sir. And currently he is working very tirelessly towards unraveling the mysteries of photocatalytic water splitting chemical reaction, which he will also be discussing during this webinar. Now, without taking much more time, I hand over this webinar to our learned speaker, Professor Ketan Patel sir. Very welcome you, sir.
Thank you. Thank you very much. Thank you so much. Without wasting any time, I'll start as well. Good afternoon, everybody who has joined. I hope you enjoy the talk that I have to deliver to you today. So the things that I'm going to talk about is a little bit, I would like to show you the current challenges that we have in terms of the energy consumption and the sources of energy that we are using and how that's impacting our environment and what the future is going to look like, and what are the things that as researchers we are potentially trying to do so that we can have a very sustainable, clean and healthy future. So as you can see a little bit from the title slide, I have, so here is just a small schematic diagram which I drew by my hand. There's the sun, there is the light, photons from sun coming and interacting with some particles here. These are water molecules. And then there is the chemical reaction happening. And here they're splitting into oxygen and hydrogen gases. And this is a very important reaction for our sustainable future. So our world is basically on fire at the moment. And if you are up to date with the news, you will see that there have been forest fires in Australia, and there is still going on a big forest fire in California as well. And these are just two examples about how the climate is changing rapidly. It's increasing, that the global temperature of our planet is increasing. And if we don't take proper measures at the moment, we're going to have a very bad future. We may get old and die, but our future generations are going to have a lot of problems. That is why the whole purpose of the talk. So why is the environment getting hotter? That's the first question. It's because of these heat-loving gases. So, for example, carbon dioxide, methane, our nitrogen dioxide, and chlorofluorocarbons. And these are some of the major gases they love heat, they absorb lots of heat in them, and that is why if they are a lot in number, if the concentration is high, they will absorb more heat, and hence the entire temperature of the entire Earth will keep increasing. Among all these gases, the most immediate attention is required for carbon dioxide. That is because the amount of carbon dioxide that is being released in our atmosphere is extremely large when you compare to all the other gases. Hence, many scientists are trying their best to come up with different technologies, somehow to mitigate the effects or at least reduce the carbon content of our environment. There are technologies like carbon capture technology that uses some chemical reactions. They use carbon dioxide from the atmosphere and they have their chemical reaction and they produce some other useful products like some fuel, for example, like biochemical fuels. So these are some good technologies taking place, but we need more. That's just not enough. Now, this is a very important graph. It shows that starting from 2400 BC, we keep on moving forward in time, but not a lot of technological advancements have taken place. Soon as we turn into human beings from these apes, we see the advancement in technology starts to take place very quickly. And this is always going to be an exponential curve because any technology that we have helps us develop better technologies faster. And the next technology will help the third generation of technologies even quicker. That is why the advancement in technology is always exponential. And what we have achieved so far is we have synthesized chips that are so small that can be transmitted into our bodies. And we have also constructed gigantic buildings, humongous architectural and engineering bodies. And all of these things have been possible because we were able to harness the energy sources that we have on our planet. So you need energy to build all these structures, you need energy for almost anything. Because of the energy, we have moved from being the early men who would just dream of making a simplest invention to a genius who has revolutionized the entire physics and modern physics. And it's all happened because of the energy. And I'll explain you how. So this is a small schematic chain reaction that I made. So let's start from here. If we have more energy, so human body, so the reason why, let me go back. Yes. So the reason why we moved from being this Stone Age people to science, to the scientists like Einstein, is because we started eating cooked food, and the cooked food gave our brains lots of energy, and that developed our brains a lot sooner, a lot quicker, and then we were able to have rationality in our lives and come up with more quick, easier solutions and make tools, and that's how we are the way we are now. So coming back to my energy population chain reaction, more energy makes smarter people, like more people are going to be smart, and more smart people will develop better technology, and with better technology comes healthier lifestyle. So instead of going and hunting by hand, people started having tools, bows and arrows, and so they were able to kill many more animals and were able to feed more of their population at the time. And more food makes more people, and then more people require more energy. So this cycle keeps on moving all the time, and it's moving now as well. Our population is increasing drastically. I think we are more than 7 billion people on Earth. And with every generation, the requirement of more energy just keeps on increasing. So, yes, that's the brain working with more energy. Now, with energy, there are many things that we achieve in our daily lives. We have the power transmission from in factories to our homes and businesses everywhere. And we use all the equipment in our house based on different forms of energy. Some places we use wood, coal. Most of the houses we use electricity. And transportation, one of the most important aspects of human civilization, is completely based on energy. You take the energy aspect out, and the entire world will shut down. And having more energy has also made us it has enabled us to transform, to be able to transform Moon or Mars. Like there are scientists and astrophysicists working day and night to find ways so that we can make Mars a habitable planet. All these things are possible because we have lots of energy, but it comes with a cost. Now, I'm bringing this graph again because there's a very good correlation between the advancement in technology and the increase in carbon dioxide in our environment. If you just take this small section, and if you correlate the small section, instead of 2400 BC, you just start at 1960, as shown in the second graph, you will be able to correlate this increase in carbon content in our atmosphere exactly with the increase in technology. And that is worrying because we cannot not have good technologies, but we also do not want more carbon dioxide in our atmosphere. Otherwise, we'll just die. Now, carbon emission is, yes, that's what we're trying to work against. One of the most important, I think one of the most major factors that leads towards carbon emission in our atmosphere is through burning fossil fuel. And fossil fuel includes petrol, diesel, LPG. So these are the fossil fuels that we traditionally use, kerosene as well. So we burn fossil fuels for many different reasons, but the thing that we want is a lot of energy so that we can go on with our lives, carry on our daily tasks. Among all the different sectors that use fossil fuels, 41%, first of all, is used to generate electricity. And this is an important section to keep in mind. I will mention this later again. I hope you have in your mind. By the way, if you have any questions, please feel free to ask me at the end of the seminar. I'll try to finish it up as quickly as I can. Now,
हाँ ऐसा ही होगा. आप सर कंटिन्यू कीजिए. लास्ट में हम एक सेशन रखेंगे जिसमें क्वेश्चन आंसर किया जाएगा.
thank you, ma'am. So 41%
ओके.
of the section that we have, the 41% of carbon emission from fossil fuels is dependent on the electricity and heat generation, and another 42%, including the industrial sector and the transportation here. Including these two things, it's again 42%. So these are two big chunks of carbon emission sectors that needs addressing. Okay, so there is a terminology called electrification and green electrification. I'll explain you what this is. So green electrification means using electricity for all our tasks and purposes. For example, like the basic things that we do, charging our cell phone, watching TV, cleaning our clothes using washing machine. Those things can be done in a green way. By green way, I mean using renewable energy sources. There are many countries now, they use solar panels and wind energy to produce a lot of electricity, so much that most of the country is actually running on electricity produced by the renewable sources. But we cannot use electricity for this 42% of the section here. The industrial purpose and the transportation. Electricity cannot replace the fossil fuel. That is because of low energy density of electricity. So every form of energy that we have, or every energy source, I should say, has an energy density which is measured in megajoules per kilogram. So how much megajoules of energy can we have in terms of 1 kilogram of that energy source? And let's go to the next slide. It will be a lot easier. Yes. So here is the energy density, what I just mentioned, megajoules per kilogram. And here is a bunch of different energy sources with information about their energy density. What we see here is hydrogen gas and liquid hydrogen. Both have the highest energy density possible at the moment. Whereas the diesel and gasoline, which is also another term for petrol, so petrol and diesel has a lot less. I think it's about 2.5 times less than the energy density of hydrogen. And if we put electricity in perspective, see how less the energy density of electricity is. So this is why we cannot use electricity for industrial and transportation purposes. So in industry, if you have had any opportunity to visit any big industry or have seen trains and aeroplanes, big ships, they require a lot of so most of the tasks that they have is lifting heavy objects, moving heavy objects. If it's some huge rotator or some big turbine that needs to be rotated, you cannot do it by electricity because of how less the energy density is. That is why we need high energy density fuels. And hydrogen turns out to have 2.5 times more than than the fossil fuels that we are using. So it gives us more motivation to find out ways to produce hydrogen in a clean way so that the entire world can run on hydrogen. Now, imagine the world is running on hydrogen. See how convenient the entire society or the entire civilization will be. So hydrogen is produced by splitting water. One of the ways to produce hydrogen is by splitting water into oxygen and hydrogen. So hydrogen is what we need from the water. So the water can be used in a small plant here that uses sunlight, and it will generate hydrogen. You can use hydrogen for your cars and for fuel cells that will produce electricity. Now you can use this electricity again to run your cars. We have electric vehicles now. And you can use this electricity in the way we are already using in our homes. We can transfer this hydrogen into a chemical plant, and we can synthesize ammonia, which is important chemical for as a fertilizer. You can also use this hydrogen and into a chemical plant, and then you can make fuel. You can use carbon dioxide from environment, and you can mix it with hydrogen and water, and you can make all kinds of fuel that we are already using, that we are digging up our earth and getting out of. So there are so many good reasons why we need to have hydrogen as our primary source of energy. And this is a nanoparticle. I'll try to explain this in as easy way as possible. So this is just showing what happens at this solar panel here. So when the sun rays are absorbed by the particles of this solar panel, it's called photocatalyst. When the sunlight is absorbed, this photocatalyst reacts with water molecules, and it has lots of electrons and holes. Don't worry if you're unable to follow. I'll explain these things in more detail as I move forward. And from 11th or 12th, you might have remembered this, the band gap of hydrogen and water, electron potential, and all these things. If you don't remember, don't worry. Just there to show you. Even if you don't understand it, it's fine. You're not losing anything. Now, coming to the most important topic here, hydrogen production technologies. So we know that we need hydrogen. So let's see how we can produce hydrogen. The first way that the hydrogen that's being produced at the moment is called steam methane reforming. What happens here is you take methane that comes out as a natural gas. You treat this methane with a very hot water vapor, and the temperature can go somewhere around 700 degrees Celsius to 1000 degrees Celsius of the steam. So the steam is superheated, and that steam is then reacted with methane, and the byproduct and we get is carbon monoxide and 3 moles of hydrogen. This carbon monoxide then reacts again with the hot steam, and more hydrogen is produced. But as we can see, we are also getting carbon dioxide and carbon monoxide, which are bad. These are the things that we do not need in our atmosphere. Also, we need high temperatures. So the high temperatures are again achieved by using diesel or coal or other, let's say, electricity to heat up the water to turn into like superheated steam. So that is not ideal. We don't want to waste lots of energy. So this is the method that we're trying to stay away from. Now, another method here is called electrolysis. And I hope you guys remember this from your high school. You use an electrolyzer. So this is called an electrolyzer. This is from Siemens company. It's one of the most leading companies in the world that produces electrolyzers. Now, what happens in electrolysis is you have your water, you provide electricity, and there are some other chemicals here that help break water molecules into hydrogen and oxygen. So here's what's happening at anode. You have 4 electrons. It reacts with 4H plus, and you get 2H2. And at cathode, you have 2H2O, and that breaks down into oxygen, 4 H plus ions, and 4 electrons. So this is basically what's happening, but there are demerits. You see how complicated the system is, and it's expensive. And again, you need electricity, which is being produced by fossil fuels, and we don't want that. We want to be as clean as possible. The next option is called photocatalysis, and this is what my PhD project is about. So photocatalysis is using photons, which is basically coming from the sun, and using a chemical called a photocatalyst. There can be many different types of photocatalyst, and what catalyst does is basically it reduces the activation energy of any chemical reaction. So using a photocatalyst, it reduces the energy required to break this water molecule into hydrogen and oxygen, and that is how the hydrogen is produced. And I will show you something really nice. So this is a small system. This is a setup. This is all you need to produce hydrogen and oxygen through photocatalysis. This is around 30 centimeters wide and 30 centimeters long. So it's 30 by 30. And this yellow thing is the photocatalyst. It's like a sheet of photocatalyst. It's called aluminum doped strontium titanate. That's the chemical name for this photocatalyst. And this is produced with our collaborators in Japan. And they are the world most leading scientific group in producing photocatalysts. So I'll show you actually what happens when you shine light. If you put light on this and add some water, this is what happens. You see these bubbles? All these bubbles are oxygen and hydrogen gas bubbles forming from this simple setup. You don't need anything complicated. So you can ask a question like, why do we not use this technology at the moment? If this is so good, why don't we use it? The reason is the cost. And that's where everything comes down to. At the moment, using methane reforming, the cost to produce hydrogen is somewhere between $1 to $3 per kilogram. But for electrolysis, it is more than $6 per kilogram. But photocatalysis, although at the moment it is equal to $6 per kilogram, it has the potential to go down to $2 per kilogram. And this is why we are more motivated to make this process more efficient. So my PhD project is to find out why this process is not as efficient as we would like it to be. Nobody knows the reaction mechanism, and that is my job as a PhD student to find out what's happening. So before I move forward, I'll have to explain a few topics so that it's easier to understand what's happening. The first thing is called vacuum. Now, vacuum is a lack of anything. And there's a thing called ultra high vacuum, which is measured in terms of torr. It's a unit of vacuum or pressure. You can say unit of pressure as well. 10 to the power negative 10 torr is what called an ultra high vacuum. To understand what this means, I will give you a very good demonstration. So imagine this is 1 centimeter cube, a cube of 1 centimeter length, height and breadth. And this is at 1 atmospheric pressure, like at our normal pressure. You are not using any vacuum machine. It is just sitting in the atmosphere. The number of air molecules at 1 atmospheric pressure in a 1 centimeter cube is these many. So you have 3 and 25 zeros of those many air molecules in just one tiny 1 centimeter square cube. But in terms of ultra high vacuum, you have only 100. So you have to remove all these using big pumps. And so it's a very challenging task. I'll show you how I do it later. So this is called as ultra high vacuum. I hope it's clear to everybody. The other thing is called ionization. Now, ionization, you may remember from your, again, high school, you shine light or you give energy to an atom, and the electrons in the valence shell get the energy and they move to a higher energy state. You give more energy, they go to higher energy states. Even more energy, they go to the most highest they can. And if you give just more energy, the electron will run away, just leave all relationship with the atom, and the atom will become ionized. That's the process is called ionization, removing one electron from one or more electrons from an atom or a molecule. And another thing is called electron hole pairs. So when you remove an electron from, like when you ionize and you remove an electron, you leave a hole there. So initially there is no charge. Electrical charge is neutral, it's 0. Number of electrons equals number of protons. But when you remove one electron out, you leave a hole. And since you are removing negative, a positive appears by itself. This is how semiconductors work, if you remember. And they propagate depending on where the electric field is. But you don't have to concentrate too much, but this is just a concept that I'm trying to explain. Now, what happens in terms of the photocatalysis on a nanoparticle? The same thing. You have your light that comes, the nanoparticle absorbs the light, electrons and holes are generated, and these electrons are then used to carry on the chemical reaction that removes hydrogen and oxygen away from each other. And the hydrogen and oxygen are produced by this. So if you look at in more details, you see that the entire reaction is in 3 steps. First, there is an absorption. So light comes on the particles, the energy is absorbed. Now comes the separation. Charge is separated. Electron and holes are separated, and then the reaction takes place. And the challenge that we have at the moment is in terms of the reaction. So scientists have been working on this project, on this problem for a long time, but they have been able to understand absorption and separation. But when it comes to reaction, there is almost no information available at this time, and that is why I'm working on this. So what happens? This can get really complicated. This is very high-level chemistry. So if you don't understand, don't worry. But try to follow. If you can't follow, note down the question, ask me later. We'll try my best to explain. So first, electron hole pairs are formed when the light is absorbed. Then you have there is a process called trapping. Don't worry, don't need to understand this. Just know that there is a process called electron hole trapping. And then there's a thing called relaxation. So these electrons that get trapped, they get stuck into certain places in the atom. They are relaxed now. They're free to move. So yeah, this is a relaxation of holes, relaxation of electrons. And then positive and negative attract each other. So what they do is they recombine, and whatever the electrons are, whatever electrons they do not recombine, they take part in the chemical reaction. And there are some other processes that happen, and there is very less information about that. And these are the reasons why these are the things that we need to understand so that we can finally know the reason why the chemical reaction is not very efficient. So what I am doing to achieve that goal is here. This is basically what I'm doing. This is my experimental setup. I'll show you at the end how this looks like in real life. I built this thing from scratch, like from ground up. What this is it's called time of flight mass spectrometer. It analyzes atoms and molecules based on their masses. So what happens is you have these two turbo pumps, and here is another roughing pump. So these three pumps work together and produce the vacuum that I just mentioned like a few slides ago. I told you about the ultra high vacuum. So this is how you achieve that ultra high vacuum. And here at the center is where the reaction takes place. And I use ionization. I ionize the products that are coming from the reaction using laser beams. I'll show you how it works. And then here is the detector that detects those ions. And then I do my analysis, and then I try to understand what's happening. So if I'm just zooming the center section here, these are the electrodes, and they are at very high voltages. This is somewhere around 3000 volts. The second one is at 1.5 kilovolts, so 1500 volts basically. And the third one is neutral, it's grounded. The yellow is my sample that I put inside. Through here, I have to load it from underneath. This is the loading mechanism. This is where I load my samples. And then I shoot the first laser beam. This laser beam is calculated. So I calculate the energy of the laser beam and how many pulses I need to basically have the effect of a real sunlight. Not more than that, not less than that, but actual sunlight. So I can know what's going to happen if I put my sample in the sunlight. And then the chemical reaction starts. After that, I bring another laser light, big, very powerful laser, and that ionizes the product. The products then go up because ions, they're positive charged ions, and you have positive charged electrons. So they repel each other. There is a repulsion, positive, positive, and so the ions fly up, and the detectors detect those ions, and then this goes to the computer. I forgot to put the photo of computer here, but just imagine this computer. So this is where it comes into my computer, and then I analyze the product and whatever the signal that I'm getting. And that's how basically I conduct my experiment. Now, just to show in a more better way what the laser ionization looks like, this is the first laser beam, and then you have your second laser beam, and the timing between these two laser beams are very important to have a good good analysis. So these are some challenges that people don't know, but only the researcher doing the experiments has to go through it. This is how it looks like in 3-dimensional. This black one is kind of my sample, and these two laser beams, this is how they're interacting. And to make to make my setup, I had to do a simulation first to see if all these voltages are going to be enough for all the products to reach the top. So for that, I use a software called Simian. It's an ion trajectory simulation software. So you can simulate electric field and how any particle will interact and behave in that electric field. So this is what I had to do when I moved here. When I started my PhD, the first thing what I had to do was finish my simulation and then start building it. And this is just basically a zoomed out view of the lens. So you see how the beam is being focused here. So this focusing is done by a lens, and that lens is called an Einzel lens. These blocks, these 3 blocks they have their voltages, and you can change the voltage to change the focal point here. If you increase the voltage, the focal point will reduce. If you decrease the voltage, the focal point will increase. So it's very tunable. You can tune it depending on your choice. And so that's basically what I have to show you today. This is my research group who I work with. We all have our different projects, but as a group, we are together. And this is the instrument that I showed you. And yeah, this is the thing that I built. And I'm very proud of it. Everything's going well so far. And I've finished the first year of my PhD. Hopefully, if within the next 2 years, I'm able to get my degree. Thank you so much. Thank you for your attention.
Thank you, sir. Thank you very much.
Thank you.
Nice
I hope you guys
topic.
enjoyed it.
Yeah. A very nice topic for your research and very useful topic, because energy conservation and energy resources are the very आज के टाइम के लिए तो सबसे इम्पोर्टेंट ये टेक्नोलॉजी
बिल्कुल।
जरूरी है। बिल्कुल अपनी ये आपने न्यू वर्ड जो यूज किया ना, ग्रीन इलेक्ट्रिफिकेशन, उसको एक बार फिर से आप इलैबोरेट कर सकते हैं अगर तो थोड़ा सा
बिल्कुल
कर दीजिए,
बिल्कुल
क्योंकि ये
इलेक्ट्रिफिकेशन
बच्चों
का
अभी
हम्म,
प्लीज करिए।
तो इलेक्ट्रिफिकेशन जो है उसका मतलब है कि कोई भी काम को बिजली के द्वारा अगर हम लोग करें, जैसे अगर खाना बनाना जो है जो गैस पे करते हैं, अगर उसको हम बिजली से करने लगे तो उसको बोलेंगे इलेक्ट्रिफिकेशन ऑफ कुकिंग। गैस के बजाय हम बिजली से इस्तेमाल कर रहे हैं।
तो ये ग्रीन इलेक्ट्रिफिकेशन,
ग्रीन का मतलब हुआ कि ग्रीन हम लोग साइंस में यूज करते हैं उस टॉपिक्स में जहां पर पोल्यूशन नहीं हो रहा है। अगर आप कुछ ऐसा काम कर रहे हैं जहां पोल्यूशन नहीं हो रहा है तो उसको ग्रीन बोलते हैं, क्योंकि हम चाहते हैं कि हम लोग का प्लेनेट जो है वो ग्रीन रहे, हरा भरा, ढेर सारा पेड़ पौधा हो फ्यूचर में। तो उसी वहां से हम लोग ये वर्ड ग्रीन का इस्तेमाल करते हैं। तो कोई भी रिन्यूएबल एनर्जी अगर इस्तेमाल हो रहा है तो वो ग्रीन मेथड कहलाता है। तो ये हो गया ग्रीन इलेक्ट्रिफिकेशन। जो बिजली इस्तेमाल कर रहे हैं वो रिन्यूएबल एनर्जी की तरफ से आ रहा है।
अच्छा, लेकिन आप एक तरफ कह रहे हैं ग्रीन इलेक्ट्रिफिकेशन और दूसरी तरफ इलेक्ट्रिफिकेशन के लिए ही आपको बहुत सारे एनर्जी की जरूरत होती है, तो फिर ये कैसे ग्रीन होगा?
नहीं, तो ग्रीन यहाँ पर सोलर पैनल से जो बिजली पैदा हो रहा है तो वो ग्रीन एनर्जी हुआ आपका, वो ग्रीन इलेक्ट्रिफिकेशन। क्योंकि सोलर पैनल छत पे लगा करके जो बिजली पैदा कर रहे हैं और जो विंड मिल का इस्तेमाल करके जो बिजली पैदा कर रहा है तो वो ग्रीन इलेक्ट्रिफिकेशन।
नॉन कन्वेंशनल सोर्सेस। एक्चुअली यहाँ भी 6 सेमेस्टर के बच्चे हैं जिनको प्रोजेक्ट करना होता है, तो उनके लिए अच्छी आइडिया है ये।
नहीं, बढ़िया बात है।
बिल्कुल बिल्कुल कर पाएंगे। सर एक क्वेश्चन है एक बच्चे का, ये आयशा महजबी है, वो लिखती है कि हाइड्रोजन लिक्विड इज मोर पावरफुल देन एनी अदर फ्यूल, व्हाई इट इज नॉट एप्लीकेबल फॉर ऑल एनर्जी प्रोडक्शन।
इसलिए अभी नहीं है क्योंकि उसका वो बहुत महंगा है हाइड्रोजन को प्रोड्यूस करना। तो कोल का अगर इस्तेमाल करते हैं हम लोग या डीजल और पेट्रोल का इस्तेमाल करते हैं, तो जो काम हम 100 रुपये में कर लेंगे, लिक्विड हाइड्रोजन को इस्तेमाल करने में 1000 रुपया लग जाएगा। इसके लिए वो हाइड्रोजन जो प्रोड्यूस होता है अभी, वो मेनली अमोनिया का बनाने में जाता है। मोस्ट ऑफ द हाइड्रोजन प्रोड्यूस वो इस्तेमाल होता है अमोनिया को बनाने में, क्योंकि फर्टिलाइजर इंपॉर्टेंट बहुत है, उसके चलते हर जगह इस्तेमाल हाइड्रोजन को नहीं हो रहा है। और हाइड्रोजन को इस्तेमाल करना थोड़ा चैलेंजिंग है, बहुत आसान नहीं है उसको, क्योंकि रिडक्शन रिएक्शन
एक्सप्लोसिव भी तो है।
हाँ, वो एक्सप्लोसिव है। मेरे लैब में एक टैंक रखा हुआ है हाइड्रोजन का जो हम इस्तेमाल करते हैं, तो उस बहुत प्रिकॉशन लेना पड़ता है उसके लिए।
वेरी नाइस। किसी और बच्चे को कोई क्वेरी है तो आप कमेंट बॉक्स में लिख सकते हैं। अच्छा सेशन था, बहुत इंफॉर्मेटिव।
होपफुली सबको अच्छा लगा। हम
बिल्कुल अच्छा लगा होगा सर, इसमें कोई डाउट नहीं है।
हाँ सर,
1-2 मिनट और वेट कर लेते हैं, अगर किसी बच्चे को कुछ डाउट
हाँ
है।
ठीक है, कोई बात नहीं।
अगर किसी स्टूडेंट को कुछ डाउट है,
हम नहीं बोले 5:30 बजे तक हम अपना टाइम आपको दे दिए हैं, अब उतना देर हम है आपके पास। मतलब मेरा 5:30 बजे, आप लोग का तो अभी 1:30 बजे।
हाँ या 1:20।
सर अभी ऑस्ट्रेलिया में है, बाकी बच्चों को मैं बता दूं कि सर अभी ऑस्ट्रेलिया में है और वहीं से उनकी पीएचडी चल रही है और अपना कीमती समय दे करके आए हैं हम लोगों को इतनी अच्छी बात बताने के लिए। तो अगर आपको प्रोजेक्ट से रिलेटेड या हाइड्रोजन एनर्जी सोर्स से रिलेटेड कुछ और कोई क्वेरी है तो आप कमेंट बॉक्स में लिखिए, आपकी क्वेरी ली जाएगी। सर आप अपना ईमेल आईडी आप एक बार डाल दीजिए ताकि बच्चों को अगर कोई क्वेरी हो तो वो आप डायरेक्ट तो नहीं, लेकिन हमारे पास भी आए तो हम आपको मेल कर सकते हैं।
डायरेक्ट भी भेज सकता है, कोई दिक्कत नहीं।
अच्छा ठीक है, तो आप अपना ईमेल आईडी आप कमेंट बॉक्स में डाल दीजिए, सारे ईमेल आईडी। और कोई क्वेश्चन तो भी दिखाई नहीं पड़ रहा है।
और कोरोना के चलते कैसा है आप लोग का पढ़ाई लिखाई वहाँ पर? कोरोना के चलते
सभी पढ़ाई लिखाई कंटिन्यूस है और ऑनलाइन, बच्चे ऑनलाइन पढ़ाई लिखाई कर रहे हैं। इवन प्रोजेक्ट भी उन्होंने ऑनलाइन ही सबमिट किया और उसकी वीडियो बनाई और उसको भेजा और इस तरह से
किसी भी तरह का अगर कोई कभी बच्चा को कोई सजेशन की जरूरत पड़े तो आराम से बोली का कांटेक्ट।
ये केतन सर ने अपना ईमेल आईडी नोट कराया है यहाँ कमेंट बॉक्स में, नोट कर लीजिए। और कुछ भी अगर क्वेरी हो तो सर को आप डायरेक्ट भी कांटेक्ट कर सकते हैं या थ्रू निशांत सर या हमारे पास किसी के थ्रू भी भेज सकते हैं। ठीक है सर, तो सेशन हम लोग यहाँ एंड करने से पहले ऑफिशियली वोट ऑफ थैंक्स के लिए अपने प्रोफेसर सौरभ कुमार कंप्यूटर साइंस फैकल्टी में उनको इनवाइट करती हूँ। ओवर टू सौरभ सर। सौरभ सर क्या आप सुन पा रहे हैं? अपने सर माइक अनम्यूट कीजिए। सौरभ सर माइक अनम्यूट कीजिए। सौरभ सर माइक अनम्यूट कर लीजिए। हेलो सौरभ सर माइक अनम्यूट कीजिए, आपकी आवाज नहीं आ रही है। माइक अनम्यूट कीजिए, आपकी आवाज नहीं। कॉल कीजिए तो सुनिए। हाँ अभी हो गया। हाँ कैरी ऑन सौरभ सर।
Am I audible, मैम?
यस नाउ यू आर ऑडिबल।
हाँ, मेरी आवाज जा रही है मैम?
बिल्कुल जा रही है। ओके कैरी ऑन सर।
Yes, ma'am. Thanks a lot for each and everything. Vote of thanks has been given to me, and it is a great honor for me. Now, I would like to say that an ignited mind is the most powerful weapon on the earth, above the earth and under the earth. And this is got through education. Education is the most profitable investment for the near future. A very good afternoon to everyone present over here. On behalf of New Government Polytechnic, Patliputra Patna 13, I, Saurav Kumar, Lecturer Department of CSE, deem it a great honor and privilege to stand before you to deliver the vote of thanks. At first, I would like to thank Principal of New Government Polytechnic, Patliputra Patna 13, for the useful webinar program of cultural exchange and educational exchange. It's obviously a lifetime cherishable opportunity which cannot be forgotten by any one of us. The lecture was which was given by Professor Ketan Patel, and who is also a PhD candidate at the University of Adelaide, Australia University. It was an interesting and inspiring one. Words are not sufficient to thank the university student and professor for spending their valuable time and beneficial cause. The interaction with the student was really outstanding. The hospitality provided here is worth appreciating. I hope that many students here will get benefited in various ways. Thanks a lot on behalf of each and everyone, and I hope this will be continuing further, and it will be a great honor for all of us, even if we call you another time as a guest. And thanks a lot from the institute. Yes, ma'am.
Thank you very much.
I hope. Yeah.
Okay, thank you, Saurav ji. Ketan sir, would you have 2 minutes? Another question is here. There is a query. Is any progress to reduce the cost of hydrogen liquid?
अब जो अभी मेरा जो प्रोजेक्ट है उस वही टारगेट वही है कि हमको खोजना है कि ये जो प्रोसेस तो कॉस्ट पहले ज्यादा इसलिए है क्योंकि हम 10 किलो सामान डाल रहे हैं रिएक्शन में, निकल रहा है 1 किलो रिजल्ट, तो 9 किलो बर्बाद हो जा रहा है, कहाँ जा रहा है किसको नहीं। तो मेरा प्रोजेक्ट वही है खोजना कि ये क्यों बर्बाद हो रहा है। तो वो क्यों का जब आंसर मिल जाएगा तो फिर नेक्स्ट प्रोजेक्ट होगा कि उसको कैसे ठीक किया जाए। तो जो 1 किलो प्रोडक्ट निकल रहा है उसके बजाय 2 किलो करेंगे, 3 किलो करेंगे, तो कॉस्ट गिर जाएगा अगर ज्यादा प्रोडक्ट बन रहा है। तो यही तरीका है अभी इसको कम करने का कॉस्ट को।
बिल्कुल हम होप करेंगे और विश करेंगे कि जल्दी ही आप अपने रिसर्च में कुछ ना कुछ बहुत अच्छा फाइंड आउट करके इस वर्ल्ड के लिए, इस सोसाइटी के लिए बहुत फ्रूटफुल रिजल्ट ले आए। ओके सर,
अगले 10 से 20 साल में हाइड्रोजन ही मेन फ्यूल रहेगा पूरा
बिल्कुल वही
जो भी बड़ा
क्योंकि हमारे पास
जितना भी बड़ा कंपनीज है, पेट्रोलियम कंपनीज, वो सब इन्वेस्ट करना स्टार्ट कर दिया है हाइड्रोजन में। और अगर आप लोग को पता करना है कि भविष्य में क्या होने वाला है, सिर्फ देखिए कि बड़ा कंपनीज इन्वेस्टमेंट कहाँ पर कर रहा है। जो लोग को सब पता रहता है कि 10 साल बाद क्या होने वाला है, तो इन्वेस्टमेंट तभी से चालू कर दो।
Thank you very much, sir. For your
Definitely, कुछ आपने टाइम दिया, ये बहुत बड़ी चीज है क्योंकि पीएचडी में तो सांस लेने की भी फुर्सत नहीं रहती है खाने की भी फुर्सत नहीं रहती है, और आपने इतना
अरे नहीं, मेरे सीनियर हमको बोले तो उनको तो ना कर सकते नहीं।
अच्छा चलिए, तो बच्चे ये भी सीखेंगे कि कम से कम अपने सीनियर को कभी ना नहीं बोलना है एक और सोशल वैल्यू भी डेवलप हो रही है यहाँ पर। ओके सर, थैंक यू वेरी मच।
Thank you, sir.
Thank you, sir.
Thanks a lot, sir.
Okay,
Thank you.
Bye. Take care.
Bye.